Hello viewers, Alan here, welcome to the workshop. So another short video. This is a follow-up to the previous one where I built some tool storage for the things that you stick in the tailstock of your lathe. And if you watch that one, you'll know I wasn't happy about the way it worked when you put the tool into the holder. The shank of the tool scraped on the edge of a piece of steel and I didn't like it. So I decided to rejig it and line the holding pockets with plastic liners. So that's what this video is about. But first up, I had to make an extension tool for holding the annular cutter that I was going to use. So that's where this starts. Let's get into it. So I want to be able to use one of these annular cutters to cut through 50 by 50 tube. So the wall thickness of the tube isn't very thick at all, so this cutter has got easily enough depth in the socket to accommodate that, but it isn't 50 long overall. So I want to make an extension driver which will allow me to push it through a 2-inch tube. This is a standard weld-on shank, so 3/4 of an inch diameter with a couple of flats at 90 degrees. As it happens, I've found a bit of scrap, which is pretty much exactly what we need. 1 1/4 inch OD, so as it stands will be fine. 25mm, which I can grab with my ER40 collets. So basically all I have to do is face it and bore the end out appropriately to accommodate that. And the only thing is that I need to have an extra, or like a sub bore at the end, at the bottom of it, to deal with the ejector pin head. I think that'll do nicely. Now get set up for well, I'll drill it first and then get ready for boring. So I think that's deep enough for the drilling. It's time to start boring. Right, I used an 18mm drill and the hole that's made marks up at 18.08. But anyway, first thing is to get the DRO calibrated with the boring bar. So we'll just do a very light cut to achieve that. I had the DRO set for 18.2 for this calibration pass. So we'll just see what we actually got. 18. That's pretty darn close, isn't it? 18.204. Okay, well, no adjustment needed there at this stage. I need a flat bottom to the hole, so that's what I'll work on next, I think. But we'll go in at 18.5. So I think you'll be able to see that's coming along nicely with a nice flat bottom hole. So I'll keep working that until I'm at the required depth. That feels pretty good. There's just a tiny bit of warmth in there. I'd say that's pretty much the perfect fit. Come on. So this is the ejector pin. So I've put a little hole at the back there which should be just enough to tolerate that, we'll see. Yeah, that's isn't going in quite as far with that ejector pin there. Yeah, looks like the hole that boss is going into needs to be at least 1 millimetre deeper. So time for a little bit of chamfering. Call that it and just take that corner off. And we'll just polish it up a little bit. I think it's safe to put my finger in there, I'm not sure about that. I think what we might do is use an artificial finger. Alright, we'll see how well that works. Lovely. Right, well that's finished the... Oh, I might just put a chamfer on that back corner. But that's finished all the operations around here for the lathe. We've just got to drill the holes, drill and tap the holes now. Okay, so we're set up for drilling and tapping. I'm using 1/4 inch UNF screws, and so it's a 5.5 hole. I use a stub drill to start with to make sure it goes in the right place. Ready for some tapping. So I think we'll have a go at power tapping this and see how that works out. Alright, well there's a bit of clean up and a chamfer on the top of that and we'll be done. Alright, turn it around 90 degrees and do the other one. Alright, so there we have it. Pretty quick and simple project. Now of course the astute amongst you will realise that because the body of the holder is bigger than the body of this cutter that I've used as the model, it won't be able to cut deeper than the depth of the thing here anyway. But actually this is intended to be used with a 1.5 inch, this is a 1.25 inch diameter body, and it's intended to be used with a 1.5 inch cutter, which I've ordered but hasn't yet arrived. So of course that will stick out past it. This might also have some limited use, I don't know, if you've got to do a hole at the bottom of something it might be useful. But anyway, its main purpose is for cutters of course which are bigger than 1.25 inch. So I'm quite pleased with how that turned out. Probably hear that's a pretty reasonable fit. Right, well my 1.5 inch or 38mm cutter has turned up, so I've mounted it in the adapter that I made, and now it's time to open these holes out. So because of the extra length of my adapter, I'll now be able to push that all the way through and straight out the bottom. And I've got a bit of sacrificial material just tucked in under there, just so I can't accidentally go too far and start cutting the vise, because this wouldn't take any prisoners. Well, I think that worked out pretty well. 5 more holes to do, or 5 more pairs of holes to do I should say. Okay, so I've cleaned this up and done a light deburr on the holes. It didn't take much because the annular cutters leave a very clean hole. And I've printed off a sleeve, plastic sleeve, and you won't be able to see it, but I included a little ridge, the thickness of the metal below the underside of that lip, so when this gets pressed in that just sort of clicks under the metal and holds it in place. So that was like Mark 1, but I realised when I had a close look that we better see that thing you were. It doesn't take all the weight. I'll rephrase it. It takes all of the weight on an edge here, which is actually hanging over the hole. So I think over time the weight of these pieces might break the tube off the flange, so I wasn't happy with that. So I've refined the design slightly, and I don't know how well you'll be able to see that, but there is now quite a chamfer on the inside here, and when the piece sits in it, all of the weight is on that rim, which is a larger diameter than the hole, so the weight of the thing gets directly transferred onto the metal, so there's no possibility of it breaking the tube off. Anyway, so that will go in there, and it's a pretty good fit, and might need a bit of encouragement from what my dad used to call an American screwdriver. He was a bit irreverent about American engineering. He was an Air Force mechanic fitter, I'm not sure exactly which, during the Second World War, and worked with a number of Americans, and he enjoyed stirring them up. Anyway, yeah, so that's going to be good. I've got another one. I'll just print the rest off and install it, and I'll bring you back when the whole lot's up in situ with the tools loaded. Okay, well, that's got that finished, and the things fit in and out quite easily now, and don't make that awful scraping sound of the shank on the edge of the sheet metal. So I think that's a good result. Anyway, hopefully you found that interesting, perhaps got an idea or two for your own projects, but in any case, thanks for watching, and I look forward to seeing you on the next one. Cheers.